So today I'm going to take a quick look at what it means to be a limiting reactant. So as you know in chemistry, we have reactants which turn into products, right? And I'm going to show you a really simple equation where we have 2 slices of bread plus 1 slice of turkey yields 1 sandwich. Pretty easy to grasp. So if I had, say, 1 slice of turkey, represented by this line right here, and I had 2 slices of bread, one here, one here, that would probably yield me 1 sandwich, right? So here's my question. What if I had 2 slices of bread and 2 slices of turkey? Right? I could, because I have this extra amount of turkey, you might go, hey, we have twice the amount of turkey, we should be able to make twice the amount of sandwiches. But understand that in chemistry, we need these things in these ratios. For every 1 slice of turkey, I need 2 slices of bread, right? Just like in real life. So in this case, because you don't have enough breads to match your turkeys, you will ultimately only make still 1 sandwich, even though you had double the amount of turkey, right? So consider this. Let's say I have 100 slices of turkey, right? And I have 200 slices of bread. This can make me 100 sandwiches, right? This is a perfect match, 1-to-2 ratio, so 1-to-2-to-1, right? Now what happens if, let's say, I had 2,000 slices of bread, right? My turkey is still the same amount. Even though I had 10 times the amount of bread, I can still make 100 sandwiches, right? What if I had 20,000 slices of bread? What if I had 200,000 slices of bread? Even though I had this much bread, because I don't have enough turkey, I can still only make 100 sandwiches. In this case, the turkey, this amount of turkey, limits the reaction. So turkey is the limiting reagent, right? Here it's very obvious. But in a chemical equation, it might be a little less obvious, so I'll show you how we solve these things, right? So if I were to do this equation out, it's very easy to say, hey, this guy's a limiting reagent. But how do we do that mathematically, right? So what I like to do is I like to assume maximum yields. I want to calculate how many sandwiches could I make with 100 turkeys, assuming I had an unlimited amount of bread, and how many sandwiches can I make from this bread, assuming I had an unlimited amount of turkey, right? So we're going to isolate this into 2 equations. First equation, I'm going to find out my turkey. How many sandwiches can I make from my turkey? So I'll do the same thing, 100 slices of turkey times, and now the equation from up here, 1 turkey yields me 1 sandwich, right? So I'll go 1 turkey yields 1 sandwich. The units cancel out. This gives me 100 sandwiches, right? Now I'm going to do the same thing. I'm going to solve this now with bread, right? So I had 200,000 slices of bread multiplied by, it takes 2 slices of bread to make 1 sandwich. So that yields me, once again, these units cancel out. That gives me 200,000 divided by 2, which is 100,000 sandwiches, right? Now, this case is pretty obvious. If one can only make 100 and one can make 100,000, and you have both of these, which one do you actually make? It's very simple in our equation. You only make 100. You make the one that's less, right? So now I'm going to give it to you in a more chemical-based equation. Right? Let's say I was going to make water. 2 hydrogens plus 1 oxygen yields 1 H2O, right? You know that. And let's say I wanted to make this oxygen. And I told you I had, say, 10 grams of oxygen and 5 grams of hydrogen, right? Now at first, this does not seem intuitively obvious because we're dealing with grams here. Here we're dealing with numbers of molecules or moles, whatever you want to call it, and you can't tell from the spot. It's big. It's clear that oxygen is bigger, right? But we're not dealing with numbers, we're dealing with mass. So we have to take into account how much oxygen weighs. So what we need to do is we convert these from grams to moles, and then moles into moles of product. And then we can compare the amount of product each one makes, right? So same thing as last time. I want to first turn this from grams to moles. So I know 10 grams of oxygen. I want to cancel out grams, put grams of oxygen on the bottom, moles of oxygen on the top, right? Oxygen weighs 16 grams per 1 mole. I'm going to do the same thing for hydrogen. Grams of hydrogen to moles of hydrogen. I know hydrogen weighs 1 gram per 1 mole, right? This gives me 10 divided by 16, which is 0.625 moles of O2, and 5 times 1 times 1, 5 moles of hydrogen. Now, it might become slightly more clear now, but still, we're still comparing reactants at this point. We need to get to moles of product. So I need one more conversion, right? Moles of O2, I know this is just plain oxygen, forget the 2. I know it's a 1-to-1 ratio, so I'm going to put 1 O equals 1 H2O, right? So the oxygen, the 10 grams of oxygen can allow me to make 0.625 moles of water. Here, my 5 moles of hydrogen, I need to still multiply that, and I'll put 2 hydrogens yields me 1 water. So I have to go 2H yields 1 H2O. Now 5 divided 2, that's 2.5 moles of H2O. Now I ask you, which one is the limiting reactant? Same thing as we did here. We look for the one that was smaller, right? In this case, this is smaller. So I can say, even though we had much more oxygen than we did hydrogen, you might have quickly said, hey, we have very little hydrogen. Hydrogen must be a limiting reactant. But we couldn't compare things based on just their grams, just on the mass. We had to convert these into not just their moles, but also moles of product, which we have here and here. So obviously, when looking at these two numbers, this one is smaller. So oxygen is the limiting reagent because it can make less overall product. This means that if I increase the amount of oxygen, I would also increase the amount of water made. However, if I increase the amount of hydrogen, in this case, it doesn't really matter what this is. If I put this as 100 million and this becomes 100 million H2O, it still wouldn't matter because we can only make this 6.25 moles because oxygen is limiting our reaction. Hope that makes sense. If not, feel free to comment down below and definitely try some practice problems with these. This will be a very integral part of most of the stoichiometry in Gen Chem. Thank you.